Mr. Ahmed here, wrapping up quadratic equations today. Today we're going to kind of look at some applications of a parabola and a quadratic function, and the most common real-world application to these are objects being thrown or projected into the air. A projectile motion equation consists of something like throwing a football or punting a football. A punt would probably be the most accurate example. If a punter punts a football, the football goes up in the air, traveling towards the other team, hits a highest point, and then works its way back down. The thing forcing it down is gravity. All right? And really we use these quite a bit, also used in ballistics and things of that nature. And we're going to look at just a couple examples of how we could use this in a real-life application. And our main thing we have to do is understand the graph. So the y-axis represents the height of the object, how high up in the air that it is. The x-axis represents the amount of time, all right? So as the punter punts the ball, it gets up to a height as time passes, and eventually it will come down and hit the ground. So this is height 0. That is the ground. The end of the equation is when that object hits the ground. And this vertex is the highest point, which we call a maximum. So that's kind of what the graph would look like. The equation is modeled in the form, the height is equal to negative 16t squared. The reason why it's negative is gravity is forcing it down, plus vt plus ho, h naught. Okay? H stands for the height. T is the time. V is the initial velocity, how fast that it's going initially. And this H subscript O, H naught, is the initial height. Because typically, the object isn't launched right from the ground. Like if I'm the punter, it's actually kicked a little bit above the ground, okay? So we're just gonna look at a couple equations to model what we can figure out. And our first example involves a ball being tossed up in the air, and it is modeled by the equation H equals 144t minus 16t squared. And it's tossed from the ground, so there's no initial height. So let's see here. It says, what is the height of the ball after 3 seconds? So that's our time. We want to find the height. So we will just plug 3 in for t. So h equals 144t minus 16t squared. When I put in the 3, make sure to use parentheses. Minus 16 parentheses 3 squared. So when I multiply this out, 144 times 3 is 432 minus, now make sure you follow the order of operations because you have to do 3 squared first. 3 squared is 9, and 16 times 9 is 144. And 432 minus 144 is 288 feet. So it went pretty far up in the air. Whoever tossed that had some power. The next question asks us, after how many seconds will the ball hit the ground? So we have to figure out when it has a height of 0. Well, obviously it has a height of 0 right when it initially gets tossed, and then at some point in time when it comes back down. So when we solve this, we're going to let h be 0 because it's on the ground. And then we have 144t minus 16t squared. That was the original equation. Now, in order to solve this quadratic, realistically, for these types of problems, our best bet's to use the quadratic formula, because typically we aren't going to get whole number solutions. So I'm going to put this back into standard form. 0 equals negative 16t squared. The t squared comes first, plus 144t, and there's no c. Now the difference between this standard form is instead of an x, we're using t. That's okay. That's just on the x-axis. It's the amount of time. So a is equal to negative 16. B is equal to 144, and there is no c, so c is 0. When I plug it into the quadratic equation, x equals negative b, so I'd have negative 144 plus or minus the square root of b squared, so that's 144 squared, minus 4 times a. A is negative 16 times c, which is 0. So that's going to cancel that whole value out. 0 times anything, 0. All over 2a. So 2 times negative 16. So when I solve this down, x equals negative 144 plus or minus the square root of 144 squared. Keep in mind square roots cancel out squared, so that's just a 144. All over negative 32. When I write out the two ways to solve, x equals negative 144 plus 144 divided by negative 32, that is equal to 0. Our other solution, x equals negative 144 minus 144 divided by negative 32. When you calculate that out, we get 9. So this kind of makes sense. 0 was when it was at a height of 0 because the ball has not yet been tossed. And then 9 seconds later, it hits the ground. And I don't know, I haven't been able to toss a ball up in the air that's been up in the air for 9 seconds. But whoever did that, they have a strong arm. So it was up in the air for 9 seconds. And I put an X. We were really working with a T. That's okay. Time. So 9 seconds. And that's all we got for that one. On to the back page, we're going to look at one more example. And this one involves a rocket carrying fireworks that's launched from a hill 190 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by the equation negative 16t squared plus 64t plus 190. What is the height of the rocket after 2 seconds? So t is 2, plug it in, and we will figure out how high up in the air that it is after 2 seconds. So h equals negative 16 times 2 squared plus 64 times 2 plus 190. When I solve this down, make sure to follow the order of operations again. 2 squared first, then times 16, that's negative 64, plus 128, plus 190, left to right when you add, and we get a height of 254 feet. So pretty far up there. Actually, not quite as high as our ball that was tossed. I don't know how that happened, but so be it. All right, next question. How long will it take for the rocket to hit the ground? So that means it's at a height of 0. So again, we have to use the quadratic formula. This one's already in standard form. So A is equal to negative 16. A and B is equal to 64. And C is 190. And we're looking when it has that height of 0, so our height is 0. Plugging it into the quadratic formula. This time I'm going to use the right variable. I'm going to say t instead of x. So t is equal to negative b, which is negative 64, plus or minus the square root of b squared. That's 64 squared minus 4 times a, negative 16 times c, 190. All over 2a, 2 times negative 16. All right, simplifying it down. Let's see what we come up with. When I take the square root, I'm going to rewrite. I used my calculator. T is equal to negative 64 plus or minus the square root of, let's calculate this out. I'm going to show you how I did this on my calculator. I'm taking 64 squared minus 4 times negative 16 times 190. I pressed enter, so I got 16,000 256. Take the square root of that. And we get 127.499. So that's 127.5. Okay. All over negative 32. Okay. So negative 64 plus or minus 127.5 divided by negative 32. Write out both cases. So t equals negative 64 plus 127.5 over negative 32, and negative 64 minus 127.5 over negative 32. So those are our two solutions. When we simplify it down, one of the answers ends up being negative. Okay, so I got negative 1.98. That's not going to work. We can't have a negative time, so that's out. And our other solution is 5.98. So it took 5.98 seconds. And that is all we have for our application problems. Have a good rest of the day.